And welcome to the webinar about how to build a COVID-19 dashboard using Dimensions data on Google BigQuery. Michele Passin, our head of data solutions, is going to do the presentation today. And before I hand over to him, just a few short housekeeping messages. We are recording the webinar, so if you can't attend the full hour, you will receive an email with a link to the recording afterwards. If you have any questions, please put them in the questions box, and we're going to do our best to answer as many of them as possible at the end. And if you have any audio issues or can't see the presentation, you can let me know in the chat box. That's it from me. I'm going to hand over to Michele.
All right, thanks very much, Ines. Can you hear me okay still? Yes?
Yeah, all good, all good.
Perfect, all right. Fantastic. So yeah, my name is Michele Passin. I head up the Dimensions Data Solutions team. Really happy today to give you a hands-on tutorial about the new dimensions on BigQuery, on Google BigQuery product we have. And specifically, we'll be looking at a demo version of this Google BigQuery product focusing on COVID-19 publications, and clinical trials and other stuff, but we'll be looking specifically at publications today. This demo version of the Google BigQuery from Dimensions is free to access, and we'll be using it to build a dashboard that essentially allows you to explore publications on this topic. And the dashboards will be relying on another Google product called Data Studio. And the reason why we picked that is because it's free. So if you want to follow up on this tutorial by, for example, customizing a bit or developing in a slightly different way, you will be able to do it, because everything we'll be talking about today is freely available online. So here's a bit of an outline of the things I'll be talking about. So first of all, I'll give you a bit of an overview about Dimensions and specifically how the Dimensions on Google BigQuery works, what it is, how you can access it, and so on. Then I'll move on to the COVID-19 topic. I'll introduce the data set we're making available as a public data set on Google BigQuery. I'll show you how to access it and how to query it. And finally, we'll open up Google Data Studio. We'll pull data from the COVID-19 data set into this dashboard developing environment. And we'll try to build a dashboard just like the one you see on the right-hand side here. So essentially, this is a dashboard that shows the the amount of new publications related to COVID-19 entering the Dimensions data set over the last year or so, plus a number of other statistical breakdowns of what these publications are about. The topics, the research areas they deal with, the organizations they are related to, their open access status, and other information that essentially helps in making sense of this really fast-growing research area. So, first of all, I assume probably most of you know what Dimensions is, so I'm going to just say very, very quickly in a couple of sentences what Dimensions is for the others that I never encountered this fantastic product. So Dimensions is a linked scholarly information platform. It's essentially, you can think of it as a very, very large database of research-related documents. You can find in Dimensions over 100 million publications, 5 million grants. You can have policy documents, clinical trials, data sets, patents, researchers, essentially all objects that have to do with the research landscape. And I would say that the most important and interesting aspect of Dimensions is that we constantly try to extract links to interconnect these different documents so that you can take advantage of this linked research landscape, and by using the links, essentially you can build interesting analysis of how publications derive from grants, or maybe how grants are related to policy documents, or how patents vary depending on research topics or countries or researchers and so on. So Dimensions exists primarily as a web application, essentially a user interface that you can use to browse the content in Dimensions, and also to carry out some pretty sophisticated analysis of the data. You can also access dimensions using APIs and more data first approaches. And those have been around for quite some time. For those of you who already know who are already familiar with the Dimensions family of products. A bit more recently, though, I think it's roughly a month ago or so, we launched a brand new product using Dimensions on Google BigQuery. So Dimensions on Google BigQuery is essentially a database representation of Dimensions. You can access all of the data in Dimensions using the SQL language. So just like you have a local database in your computer or in your local server that allows you to query directly the data in Dimensions. But BigQuery is actually a little bit different than a traditional database. It's actually a cloud data warehouse. So I think that's a very nice way of summing up what Google BigQuery is. So cloud, what that keyword refers to is the fact that Google BigQuery is fully hosted on the cloud. You don't have to do anything yourself. You simply have to get access, and you can then start using the database right away. You don't have to do any setup on your local infrastructure. And finally, it's a data warehouse, so that's a little bit stronger than a database. What that means is that it permits to have multiple databases within it, and it's really geared towards the integration of multiple very large data sets. As you will see, there is a growing number of public data sets hosted in Google BigQuery. Each of these can contain terabytes of data. And by using BigQuery on the cloud, you don't really have to worry about the size of the data sets or the time it takes to query them, because it's actually extremely fast to perform operations on these data sets. You can also join essentially these data sets together in a very similar way as when you would do a join using a local database. And that essentially opens up a very, very large number of possibilities in terms of essentially taking advantage of the work of different projects or different groups within a single application. So one thing to keep in mind is that BigQuery fundamentally is your product. We give you access to dimensions on BigQuery, but you would access this data using your own Google account, your own account details. So you can also put other data on BigQuery. You can put your own data sets. You can use data sets from other collaborators, but fundamentally, you're accessing a space that you control fully. The other nice thing about BigQuery is that sharing data sets is extremely easy. So essentially what the Google guys did is trying to replicate the same approach, the same very successful approach they had with Google Docs or Google Sheets, whereby you can, very quickly share something with other people. So they try to replicate that with data sets. So Google BigQuery allows you to essentially generate reports or to create data sets that you can easily distribute or share with your colleagues. And finally, the key thing about BigQuery is that it uses SQL for performing queries. So BigQuery is not 100% the traditional SQL database. As you will see, it contains some features such as repeated fields or structure fields that are a little bit closer to the NoSQL family of databases, but you can still query 100% using SQL standard. What that means that, for you or the people in your team who have been doing SQL development in the past, it will be a very, very quick learning curve in order to get going to do something useful with BigQuery. So I did mention the family of products we have within Dimensions. So this slide just gives you a quick overview of how BigQuery fits in within this family. So of course the web app is it's our flagship product. It's what you probably go to in order to do some pretty straight quick search and discovery task. It handles a number of top analytical use cases that we know from our customers are very, very important. Of course, there's a user interface, there's a number of visualizations that come with it, and it doesn't really require any specialized knowledge if you want to use it. So you can actually get up and running pretty quickly with a web application. We also have APIs. APIs allow you to do more ad hoc analysis. So if there is some analytical use case that the web app doesn't allow you to do, you can probably do it with the API. The API works over HTTP. It's similar to REST APIs in many ways. So it's more geared towards pulling data, not too much data per query, but you can pull a lot of data by having many, many, many queries. So I would say the main reason of existence of the API is to permit the integration with some other application out there. So you may have some other software tool you're working with or some other system you're building, and you want to pull data from dimensions regularly. You don't really care about large-scale analysis of the data, but you want to have a constant feed of data coming from dimensions to your system. And that's what the API is for primarily. Google BigQuery is a little bit different. It's not really geared towards a regular integration with other tools, but it allows you instead to run some very, very large analysis of the data in a very, very short amount of time. So for example, imagine you want to compare the total number, well, the full publications landscape for one research organization with the publications output of another research organization in terms of citations or other metrics or collaboration patterns and so on. If you had to do that with the API, you probably have to pull all of this data first from dimensions and then run the analysis offline. That's perfectly doable, but pulling all the data for some very large organizations, it can take you many hours. With Google BigQuery instead, you can simply write a SQL query that does that, and you can do it in real time. It will take you seconds. So that's a real advantage with BigQuery. When you have some really large analysis of data, involving dimensions data, of course, it's really, really fast and performant to do it. Of course, the other nice thing is that since everything is in the cloud, it becomes also very, very easy to join this data with other private or public data sets you might be interested in. And also, it integrates directly with other visualizations tools such as Tableau, Click, or Power BI. All of these tools, they normally have a built-in BigQuery connector that allows you to pull the data straight into your business intelligence tool of choice. Finally, the other option some of you may have heard about is the bulk data experts. So that option is specifically for those of you who already have an established architecture for pulling data into your systems. So some sort of ETL, which is already up and running and is able to essentially consume dimensions data directly. Of course, that takes a lot of work to set it up. So that's why I'm saying this is primarily for folks who already have a data ingestion pipeline, because that's normally costly to put together. But if you do have it, we can also offer you the actual raw data behind dimensions to consume. So just to sum it up, dimensions of BigQuery, what does it mean in practice? Ultimate flexibility. It means you can think of any queries of any complexity involving any amount of data. You should be able to do it with BigQuery, no problem, and it will be pretty fast. Speed and agility. You can aggregate and manipulate the data, as mentioned, at a very high speed. And especially if you have been using the API, if you've been trying to do this same sort of things with the API in the past, you will see a massive difference in how things can be done with BigQuery in this respect. And finally, the interoperability with other platforms and data. That's another very strong feature of dimensions of BigQuery. You can easily access the data from any of the visualizations or intelligence platforms you have been using in the past, as well as combining the BigQuery data with other data sets on Google or with your own data sets. One specific applications built on top of BigQuery is the ability of building dashboards. So dashboards or reports, interactive reports, are a really powerful way of conveying meaning generated from an underlying data set. Essentially, there are a collection of different visualizations and charts, tables, summaries of the data you're analyzing to the end of essentially explaining bringing forward some insights, letting users see an overview of the data they're looking at, and understanding a bit better what the research landscape is about. So the dashboard snapshot you see here is the COVID-19 report we generated a few weeks ago. This is freely available online, and it's been built with Google Data Studio. You see the URL for the report right there. At the end of the tutorial, I'll be sharing the slide URL, so don't worry about taking notes now. You'll be able to get to this stuff later as well. Key thing to remember here is that the COVID-19 data set is fundamentally a slice of dimensions on GBQ that contains only COVID-19 related documents. So we developed a full text search query a few months ago together with some colleagues and librarians who are experts on this field. And essentially, we apply this full text search on the dimensions data sources every day, and we essentially single out the publications, the patents, the clinical trials, the grants, and so on that match this full text search. And then all of these are exported every day, and they're made available for anybody to consume. So for a while, we have been sharing this data set using Excel. Essentially, there was an Excel file being shared on Figshare, and it still is actually shared on Figshare if you look it up on the Dimensions website. But recently, when when the BigQuery product from Dimensions was launched, we also created a new version of this COVID-19 dataset fully on Google BigQuery. Now, as I mentioned, Google Data Studio is a powerful tool and it's a free tool for building dashboards, and that's the one we will be using today. But it's not the only one. We know many of you, and actually we also make use a lot of other tools such as Tableau, Click, Plotly, and so on. And so you're not really limited to Data Studio in any way if you want to build reports or dashboards, because there are connectors for Google BigQuery for all of these different business intelligence tools. And the other thing that I've mentioned, but I'll probably say it again because I think is a really interesting feature of this environment, is the fact that you can easily integrate your organizational data or other data sets you find on Google BigQuery with the Dimensions data in order to generate more added value from all of this. All right, so the COVID-19 data set is available online. We'll take a look at that in a minute. The other data set we have made available online as a public data set is GREED, the Global Research Organizations Identifiers database, which you may already know of. We use these identifiers, this database extensively within Dimensions in order to disambiguate affiliations and other organizations' data. So the GREED dataset was already freely available online. Now we've simply created a version of it on Google BigQuery. So you can make use of that as well. Finally, I haven't really talked about the Google BigQuery documentation much, but I should stress that this is really one of the main resources you want to keep in mind if you want to get started with Dimensions Google BigQuery. You will find sections that show you how to get started, how to set things up on Google Cloud if you're new to this environment. There are some example queries in here you can play with. But most likely the section you'll be spending time on it will be this data sources table section. So this is where we describe in a very detailed way what is the data model we are using, essentially the different objects that are represented in Google BigQuery. And for each of these objects, we essentially describe what are the fields, the different data points that are available for them. So for example, now I'm clicking on the publications data source tables, and you can see down here the schema for publication. And this is essentially a long list of all the fields you can find in the publications table. And for each of them, you can find out whether what data type it is, and a short description summing up what the field is about, And if you click on the question mark here, we also have a very nice feature here that shows you a quick snippet, which is essentially the actual data you would find in the table for this specific field. So I'm going to head back to the presentation here. Right, good. So today's tutorial, hands-on session. Essentially, the goal here, we want to create a dashboard that allows users to discover and monitor publications related to the COVID-19 topic. So we'll be using the COVID-19 dimensions dataset for that on GBQ. And the end result will be a Data Studio dashboard that will allow users to navigate these different publications, look at the metadata, you know, things like title, DOI, the user stuff. It would also allow users to highlight time-based trends about the publications. For example, how many publications we have every month or every week, and also discover publications of interest by manipulating other dimensions of the data. So for example, the organizations or the countries authors are affiliated to, or the subject areas of these publications. Right, so here we go. So the hands-on session is divided into 3 parts. First one, a simpler one, I would say, is about data access. So we look at how to actually, connect to this data set online and how to be able to query it. The second one will be about building a query. At the heart of a dashboard, I would say there is the data that the dashboard essentially displays or simplifies. So we'll be spending a bit of time on the specific SQL query we'll be using in order to build the data set behind the dashboard. And finally, we'll actually, move on to Data Studio and start building the dashboard itself. So these are the 3 parts. I'll try and get through all of them, and then leave some time at the end for questions or comments in case you have any. All right. Okay. So data access. So there's 2 things you need to have in order to access the COVID-19 dataset in Google BigQuery. One is a valid Google account, and normally, if you have a Gmail email address, you already have a Google account. And the second one, you need to have a Google Cloud account. That's actually pretty easy to set up. You simply have to follow up on this link, and then if you don't have it, you'll be asked to set one up. You need to agree to the terms of service, going through the usual steps to make sure everything is in order, and then you will have a GCP account. Right, once you have that, you need to navigate to the BigQuery dashboard, which is part of Google Cloud. So BigQuery is one among many different products Google Cloud has to offer. So I'll show you what that looks like in a minute. And then what we'll be doing is creating a new project that we'll be using in order to run these queries. Of course, you want to give the project a name. We can call it COVID-19 COVID data demo. And then once you are within the project, we can look up the COVID-19 Dimensions AI dataset and import it, access it using your project credentials and try out a couple of queries to make sure everything works. So step number 1, I'm going to go to the Google Cloud console here. Since I've done this already a couple of times this morning, it's not asking me anymore to agree to the terms and conditions, so I'm already in it. But once you click yes on those usual pop-ups you get, you'll be arriving on a page like this. One thing to point out about this dashboard here is that if you click on the left-hand side on this sidebar here, you will see that there's a very long list of products from Google Cloud. This can be pretty scary, especially at the beginning, because there's really a lot going on. So what you want to do the very first time you do this is to scroll down till you find BigQuery, and I suppose, if I remember correctly, it's under Big Data. Once you get to BigQuery, I've already pinned it, but it's a really good idea to pin it, because once you do that, BigQuery will appear at the very top here, and you'll be able to get to it quickly, right? So now I'm inside BigQuery. As you can see, this is a kind of a web-based database database access tool. It's called the BigQuery console. Uh, it's actually a very powerful tool, especially if you want to try things out. You want to see how queries perform. You want to see what the database structure is, and so on. So it's something you'll probably be using a lot if you're going to do more work with BigQuery and Dimensions AI on BigQuery. Anyhow, once you get to this page, the next step is to get access to the COVID-19 dataset. Now, there's two ways to do this. You can either go back to the presentation here and follow one of the many links we have to the COVID-19 dataset on GCP. So now I click on that. You will end up on a page like this, and you'll be able to click on the data set and essentially get access to it. So that's one way. The other way is simply going from the console to the Add Data menu here, click on Explore Public Datasets, and search for dimensions. I really like this way of getting to it because it really shows you how much stuff you have in here already. So for example, if I search for chemical datasets, as you can see, there's a Campbell in there, another database about network-based cellular signatures. Let me say, if I search for country, there's a lot of other stuff on COVID-19 by country. There's all sorts of data sets that are readily available. These are all public data sets, so things that you can access right away using BigQuery. So in our case, of course, we're looking for the Dimensions COVID-19 data set. So there it is. I'm going to click on it. Here we go. So we're back to the landing page for this data set. I'll click on data sets, and now I should be going back to the Google BigQuery console here. And as you can see, the data set now appears on the left-hand side here. The very first time you'll do this, you'll probably be asked to set up a project as well. I've done it already. It's called COVID-19 demo. You can always set up a new project if you want and essentially link the dataset access to a specific project. That's a very important step. It's easy, but you have to do it all the time, essentially. Adding a project that links, that kind of describes your access to a resource. Now I'm going to open up the COVID-19 dataset here. So the way things are structured in Google BigQuery is that you always have a top-level project. That's COVID-19 Dimensions AI. Within the project, you have a data set and then a number of tables or other resources within the data set. So data, that's essentially the name of the data set. You can think of it as a database. And within this data set, there's a number of tables. If I click on publications, I'm going to bring this up a bit. We can see here the publication schema. And that's exactly the same schema we were looking at a minute ago here in the official documentation. And we can run queries. So before running a query, I think let's go back to the slide for a second, because essentially we completed the first part. You know, we got access to the COVID-19 dataset. So next step then is, like I mentioned, building queries. So I prepared here a simple Colab notebook. This is essentially you can think of it as a Google document that contains code and text. Colab is another product from Google. Lots of products from Google today, but by all means, all of this can also be done without all of these products. You can use different versions of notebooks, Jupyter, for example, to do this, or different tools to visualize stuff. The dimensions of Google BigQuery will still be accessible from the cloud. So in this notebook here, I put together a few queries we'll be using today for the specific purpose of pulling data related to publications from that data set. Now, there's two ways of trying out these queries here. You can either essentially follow the notebook here and click on each of these cells um, and then run the queries. So the very first cell here essentially sets up a connection. It allows me to authenticate with Google. So I'm going to click on that. All right, I'm going to get now a code, put it back there. Right, and now I'm authenticated and connected. Once you're authenticated, you can use this little magic command to run BigQuery queries from a cell. You always have to pass the project ID, so the project you are accessing your data sets from, otherwise it won't work. So my simple query here, essentially, I'm counting how many publications I have in my, well, in the public COVID-19 dataset. So I'm going to run it, and this now tells me, 182,000, which is already quite a few more compared to a couple of days ago when I first tested this. This field is really, well, unsurprisingly booming. One thing I should point out about this query here, as you can see, when I have a from statement, the structure of the object I'm referring to reflects the Google BigQuery structure I mentioned to you a moment ago. So what I have here at the very top level, that's the project. So COVID-19 Dimensions AI. That's always the same name because that's the name that name comes from us, from the Dimensions team. Then we have data. That's the name of the database. And finally, we have publications. Publications, that's the table, right? So as I mentioned, you can either run the queries from here to try them out. The other nice way of running the query is to essentially copy paste the query in the query console here. The nice thing about doing this here in the query console is that there's a number of other useful functionalities. You can export the data, different formats. You can save your query. You can schedule the query to happen at specific times. So there's a number of quite useful things you can do in here. I can export to Google Drive directly. I can export the results to Google Sheets. So that really simplifies the process of essentially moving data in and out of this environment. So I think from now on, I'll try and use this console primarily simply because it will help us in it will make it easier to inspect the results of the queries we get. Right. So as mentioned, there's 180,000 publications in the COVID-19 dataset. That number of publications is growing all the time. So something we want to try and do is to look how quickly this total number of publications grow every month, right? Now, the way we do this, for those of you who are familiar with SQL, it's actually pretty straightforward. Essentially, here I'm saying, give me the total count of publications. I'm using a specific field called date inserted. Date inserted essentially tells you about the specific day when a publication was added to the Dimensions database. So I'm taking the month from the date inserted, and I'm using that month to segment my data. So I have a group by month statement here. And also, I'm looking only at publications from 2020, just to keep this analysis a bit more focused. I'm sorting the results by month, so I'm going to have the most recent months first, and then for every month, I'm getting the total count of publications. So the results are coming through here. You can see month end, that's October, is not finished yet. There's already 24,000 publications. Then we have September, 20,000, August, 26, and so on. As you can see, the number of publications is pretty much constantly growing, and that's certainly something we want to also visualize in the dashboard we'll be building after we have a proper query. So now back to my notebook here. So what we want to do is essentially pull out publications information from the database. I would say the very basic place to start from is to pull out the standard publication metadata. So things like title, DOI, year, title of journal. We want to know essentially what the publication, what journal or publication is associated to, the publication type, and then the date it was added to dimensions as opposed to the date it was published. For many of these publications, the publication date could be in the future. So for this analysis, the date inserted in dimensions is probably more interesting because it tells exactly when something was actually made available online in some form. So that's a very basic query there. I'm going to run it from here. And the data coming back. Boop, boop, boop. As you can see, sometimes queries take a little bit longer to run from a notebook compared to the console. So that's another reason why using the console could be is often very useful. So here we go. So I get my list of publications here with ID, title, DOI, the usual suspects. As you can see, sometimes journal is empty. It says none. And that's the very first thing we want to modify. And the reason why journal is absent sometimes is because, of course, Dimensions has many different publication types. It's not just journal publications. It could be, preprints or so publications from preprint servers. It could be books and so on. So the very next thing we want to do is to modify that journal title by essentially taking the very first venue title field available for that specific record. So if it is a journal here, it will be the journal title. If it is a proceedings volume, it will be the title of the proceedings. If it is a book, it will be the book title, and so on. And we use this function here, coalesce, that essentially takes the very first non-null value from these fields, and we call it venue. And so that's the new version of my query here. Oops, I deleted that by mistake. I'm gonna get back to this. I'm gonna run it in here. It's complaining about something. Let me see. Okay, it's not O, but it's P. Stands for publications. There you go. This should be working now. There we go. So now I have same metadata coming through as before. Instead of journal title, I have venue. And as you can see, sometimes I have a chapter and I still get the title of the book. In this case, the chapter comes from. Here I have a proceeding publication, and that's the title of the proceedings. Some null values still there in articles. That's probably because the article doesn't, there's some error with the data at the source, and there's no title available in that case. All right, so we have some basic metadata for our dashboard. So the next thing would be to pull out other information about research organizations. So the reason why I'm pointing out research organizations here is that this highlights a feature of Google BigQuery which may be new to some of you. This is called repeated fields. So if we go back to the console and we open up the publication data structure, you will see under mode here, the some fields, they don't say nullable, but it says repeated. What that means is that the contents of this field here, this row, can be a list of things. So, the concept of it is not, extraordinary. It makes sense. Instead of having one single ID, in this case, I have the full list of researcher IDs related to a publication. Or down here with research orgs, I have the full list of research organizations related to a publication. So the only gotcha here is that when you query this data, you need to use a special construct Google BigQuery makes available, which is called unnest. So the unnest operation is essentially a way of saying unpack the items in this list and make it available in a row by row fashion to the source data. And this little query here shows you how that works. And the reason I'm also using a left join here is because if I didn't, I would only see publications where there is at least one research organization associated to it. And keep in mind, these research organizations are only the disambiguated research organizations that have a grid identifier. Of course, every publication has affiliation strings somewhere, but of course, not all of them can be disambiguated. So this field refers only to the disambiguated one. So by saying left join and nest research organizations, what I'm getting is the full list of publications from the COVID-19 dataset, and then in the research org grades column here, if there is a grade identifier, I can see that as well. Otherwise, I won't. Now, grade identifiers, of course, are nice because they're unambiguous, but they're not really what people want to see in a dashboard. So we want to have, the names of these organizations, the countries and cities and so on. In order to achieve that, we can do another join on the grade table of the COVID-19 dataset down here. So this grade table is essentially the full grade dataset, the full grid database. So if I'm copy pasting that query in there and I'm going to run it, you will see now that I get a full list of grid identifiers as well as the name, and when available, I'm only pulling out the name in this case, but I could be adding also grid.country. Let me see, is it called country? It's address.country. There we go. So we got countries for the organizations as well now. All right. So now, putting all of this together, we have the query from before. We've added the research organizations by using the nest operators. We've added the grid information. So for every research organization, we also have things like name, country, city, and so on. And so we have a much richer query we can use now to pull publications related data. Let's see if it runs correctly. There we go. Okay. So very last step. Now that we know how to use a nest, we can essentially use it on other fields as well. And the two extra fields I'm going to bring into the mix here is research categories and open access information. So the way these are used is actually not different in any way from research organizations. It would just make the query longer. So that's a new bit we're adding. So we're essentially unnesting the open access categories information and unnesting the field of research categories in our query. That's all that is happening here. And of course, up here, when we do select fields, we also add these new fields we want to show up in, we want to get in the results. So I'm going to copy this very final query and run it again to make sure everything is okay, and then quickly move on to the dashboard creation bit. So what we have right now then is a query that pulls out, as you can see, we have open access categories, we have category information when available. Well, for those publications, there isn't. And then we add the grid data. So we have a pretty nice query right here then that extracts from the COVID-19 dataset some key data points about publications that we can use in our in our dashboard. Right, so this allows us to move on to the part 3 of this tutorial, building a dashboard. So we have our query. We know that the data coming through is actually the data we want. So now we can open up Data Studio. Or if you wanted to replicate this using Tableau or something else, you will be opening up your business intelligence tool of choice. But fundamentally, once you have the query, now that's the time when you want to start looking at building a report. So you open up Data Studio, and the very first thing it will ask you is to whether you want to create a blank new report or not. I've chosen a blank report here. You need to add some data to the report, and guess what? The data we want comes from our query. So I'm going to click here on BigQuery because that's where the data is located. I'm going to click on Custom Query because that's essentially the way to enter the query I just developed. You always have to keep in mind what is the project you use to access that data, because essentially that has to do with permissions, and it always has to be known to Google products. So COVID-19 demo is the name I've given to my project. So now I'm going to go back here, copy the query I was just testing. I'm going to paste it in here. Hopefully there are no typos. And this query, well, the data coming through thanks to this query will essentially be the main data backbone of my dashboard. All right, so that worked. As you can see, some data is coming through already. I'm going to give this report a title. Oop. There we go. So I'm going to start building a few visual representations of the data here. So the very first one, I want to have a simple table view, essentially a table showing the main, the most important metadata we have for these publications. So I'm going to title, type. I'm using here the dimension section of my data configuration panel, because these essentially are all the different ways I'm breaking down my my table with. So I'm going to have a title, type, venue, and then I should have a publication here somewhere, date of publication, and there's probably and DOI. That's always useful. Then the other thing to keep in mind is that in Data Studio you always have dimensions section, which essentially tells you what are the different aspects of the data you want to display, and then the metric section. The metric section it tells you how you want to essentially sort, count, or score the data with. So in this case, I have record count selected. That's not what I want. In my metric, essentially, I want to know for every publication what is the score associated to that publication, and then how many times the publication has been cited. There shouldn't be, there should be the minimum score and minimum all metric, because there's only one value per publication. And right, so my table is coming through here. I'm going to modify the table so that it becomes a heat map. Essentially, the metric columns will be color coded. And also, I'm going to sort the table by all metric score first. So let me put all metric score as the last one here. Good. That's looking okay. Let me make the report a little bit bigger. We're going to add more widgets to it. So now the height is set to 900. We're going to make it 2000 pixels to begin with. I'll bring this one down here a little bit. Make it a little bit bigger. We can show 20 results by default. As you can see, some interesting patterns already begin to emerge. Here we have some publications that are cited a lot, but the Omagic score is not as high as others. So that's something, be useful to follow up on afterwards. I think what we want to do now is add a title, COVID-19 report. We can make it a little bit bigger. All right. Okay. So I'm going to build a little bit of a header here, and we can add very quickly these scorecards visualizations here. These are essentially little cards that show you a summary of some dimension. So in this case, I want to know how many publications I have in total. So I'm going to use the ID here. Every publication has a unique ID, so I'm going to count the total number of IDs. I can rename that to publications. So that's my first scorecard. I'm going to add another one where I can essentially show how many publications we had in the last month. I'm going to bring ID back there. Let's call it this month, actually, versus last. So what we're going to do here is to apply a custom data range. I'm going to say here somewhere this should be last week, this month. Actually, this month to date. It's more precise. We can even add a comparison. So we want to compare this month to date against last month to date. And see, there is a very nice built-in feature in Data Studio that does that for you pretty quickly. So that tells me how many publications this month against last month. Finally, I'm going to add also another couple of cards here to display the total number of research organizations we have in here. So the field here is grid. I want the count of distinct organizations. And finally, we can have the count of distinct countries, which is also interesting. So I'm going to bring country there. There you go. So 188 countries, 16,000 organizations, and a few more. Let's make that a bit bigger. Okay, right. So we got something going already here. So the next thing we're going to add is a timeline. Timelines are always useful. So we want to have a time series chart here that shows us how many publications we have. Well, how many new publications we have in dimensions every day, or possibly even every week. So the dimensions here is data inserted. The metric, essentially the thing I'm counting here, it shouldn't be the Omagic score, but actually the publication ID. I'm counting unique publications per day. That's already a distinct, so that's fine. This is probably not too interesting. Well, it looks a little bit too ups and downs, and that's because we're showing the results per day. I think what we want to do here is to show maybe results on a weekly at the weekly granularity. So I've selected here ISO year week. Right, that's it. This is a bit more interesting. It shows us how many publications we have every week. We can even add this chart, make the chart a bit more interesting by dragging type into the breakdown dimension. What that means is that we're showing essentially how many articles versus chapters versus other publications types we have every week. And so that's our first chart right there, ready to be used. Next thing we can add is a simple, say, breakdown of open access information about these publications. So in this case, the dimension I need is the open access category. I'm going to drag it in there. There you go. Now, as you can see, the way open access is set up in dimensions, open access fields, there is a value called OAO, which is a bit of a shortcut because we have stuff which is gold, green, gold hybrid, and so on. So all of these things will go into OAO. So that's really an aggregation that counts from dimensions directly. We don't want to show that in the chart because that repeats some of the other stuff we already have. So we can get rid of it actually pretty quickly here by adding a filter to this chart. We simply say exclude my open access field when equals OAO. We don't want to show OAO essentially. That's it. Okay, and we got our open access chart. Something else we can bring into the mix pretty quickly is a map. Maps are always nice. We got a field map. I'm going to put in a geo chart, and my map should essentially show what are the countries and the cities publications are related to. So I'm going to enable drill down here because I want to be able to zoom into the map. I have country and city, zoom area, no problem. We don't need that. Right. I'm still counting IDs. So single publication, that's something we always have to make sure that in my metric here, we're counting IDs and not anything else. So we want to represent essentially the number of publications per country in this chart. And I'm going to add a few other things. Let me scroll this down, bring this down a bit more. Okay, so we have fields, research areas. It's always something useful to display on a map. Tree map is a really nice way to represent research areas. I'm going to do it like that. In this case, I need to bring the field category FOR. Here we go. Can maybe change the color a little bit to make it a bit more interesting. Let's make it go from green to blue. Probably not very good with colors, but there we go. It's a bit better. As you can see, there's a big category there which is empty, and that's actually null. That's all the papers that have no category. So this is now very useful to display. So I'm going to get rid of it, just like we did it before. I can add a filter for this specific. Can create a new filter for the specific visualization, and I can simply say exclude. I have my category FOR field down here. I want to exclude categories when they're null. So the reason why there's null categories in there is because some publications that are picked up by dimensions don't have abstracts available yet, or maybe the full text is not available. So these categories which are applied to dimensions automatically are not available right away. Some point in the future they will become available, but right now they are. Okay, that looks a bit better. And then finally, because I'm aware of the fact we're running out of time, I'm going to add a list of the organizations, of course. That's also useful. So we have countries and cities there. I want to be able to see what are the specific organizations we're dealing with here. So for that, I'll simply add a table, a heat map, a table with a heat map, and I'm going to have the grid name there. And the country. So this is useful because we can then you see how we can use the other filters on this page to filter down the results in this table. And so looking at the organizations list is a nice feature. Also here, the first result is null. A bunch of affiliation have not been disambiguated yet. So I'm going to remove that from the chart because it's not very useful. So from grid name, I'm going to say remove null. And that's it. We got this basic dashboard up and running. Maybe the very last thing we can do is update the layout a bit. So I'm going to click on that. There's a number of themes that come out of the box with Data Studio. Some of them are quite eye-pleasing. So I'm going to click this groovy theme here. There we go. I'm going to make sure things are a little bit more in line. And then I'm going to try out the dashboard. So up until now, I've been in edit mode with the Data Studio dashboard. So if you click on View up there, you'll be able to see the dashboard just like your end users will see it. Right. So as you can see now, I can click on these things. I mean, I get information about how many publications I have per country and so on, but the whole thing is really not interactive. So there's one thing missing. So if I go back to the dashboard, you will see for each of these charts, if you scroll down, there's a little bit checkbox here that says apply filter. So I need to make sure that all of my, oh, that's not available for a scorecard, that all of my charts are have that checkbox enabled. What that means is that I can interact with them, meaning that when I click on these charts, the other stuff would also update. And this is fundamentally possible because I only have one query behind this dashboard. So Data Studio knows essentially how to modify the query in real time based on the things you're clicking on. So back here now, so let's say I want to focus on UK authors. So I clicked on UK. As you can see, all the rest is also updating. I can look here only at the UK-based organizations publishing this area. I can maybe filter down by research area. I just want to look up psychology papers related to COVID-19 from the UK, and actually I want to be able to read that paper. So I want to look at the gold bronze papers. I want to be able to look it up online and download it. So everything is updating. King's College London is the very top. And if I scroll down here where I can see my list of papers, I can actually see the details for all of them, yeah, in case I want to follow up. And that's in a nutshell how the interactive dashboard works. I think there's one very last thing we want to do here. And as you've seen, I can scroll down and look at the list of papers here. But of course, I need to copy paste the DOI or the title to look it up, which is really not ideal. So we can do something to speed this process up. And that's actually quite easy. I can simply create a field. What that means, I can create a new generated field that uses some of the data I already have in my query. So I want to be able to link back these publications to the Dimensions homepage for that publication. So now the Dimensions URLs are pretty stable. They always start with the same URL prefix. So I can use the publication ID and the title to essentially create a hyperlink. Now, I won't go too much into details about this, but essentially these Data Studio commands, they allow you to concatenate two strings, in this case, in my URL template, and the identifier of the publication, and then I show the title as the visible feature of the hyperlink. So I'm creating a new field called title link. Let's see what that looks like. I do apologize for running over time. Hope you're learning about stuff. So that's my main goal for today. So I'm bringing the title link field, this new field here, getting rid of the old title field there. So back to my table, I'm gonna adjust it a bit. It's re-rendering it. Okay, so things look okay. Of course, the column names, column titles, could be changed so that, to make it look a bit better. When I have type there, DOI, and I have my title link right there. So now I think it's time to test it out. So let's do view again. Here we go. So let's pick another country now. Let's look at publications coming from New Zealand on the COVID-19 report. Back to our psychology subject. And gold, bronze publications. So things I can actually follow up on. And here I have my publications list. So now I can actually click on these guys here, and the publication landing page on Dimensions will open up right away. So what I've just built then is a essentially really nice bridge between a dynamic report that people can use to navigate a specific view of the data based on my requirements, and an index of publications that can be used to follow up on this publication. So I click on View PDF in Dimensions there, and I should be able to open up the PDF for this publication right away. There you go. I think this is really the end of it. I'm going to stop right here, see if there's any questions, and once again, apologies for running over time a little bit. Okay, I can see there's a bunch of questions here already. So the first one from Amanda, what is the code you could use to visualize your specific university's publications in COVID? Well, at the level of the query here, you simply would have to add another where statement here. So here I'm saying where year blah blah blah. I would say where research org ID equal your organization's ID. Yeah. And to find out your organization's ID, probably the quickest way to do that is to go to the GRID website or to Dimensions. GRID website is probably a good place to start, and you search for your institute there, and you essentially find the GRID ID. So that's how you would do it. Are you able to share a link to the Colab notebook, please? Yes, I will. It will definitely be shared afterwards. I'm going to put it in the chat right away. We will be sharing the slides, the Colab notebook afterwards, everything else. And by the way, there will be a tutorial containing the same contents of the things I discussed today. We become part of the official Dimensions BigQuery documentation. So that will be announced shortly after this event. I think by the end of tomorrow. Oh, hello, Angelo. Jose, thanks for comment. Let's see, Rosalina is saying, is the grants data of COVID-19 also available through Dimensions? Yes, yes, it is. I haven't shown you that yet, but if you go to Dimensions AI/COVID-19, this is the main landing page for COVID-19 resources we are making available for free. So you can browse this data in the web app. So click on that link, you'll be taken to a view of the web app showing only the COVID-19 resources. That's the dashboard I was talking about earlier. That's a BigQuery data set we have been using today. And then this is the Excel spreadsheet containing all the raw data for the raw metadata for publications, grants, clinical trials, and so on. So these are the four main things where we are making available. So Amanda is asking again, is there a way to combine this data set with another one, like a data set that has university departments, to segregate the COVID publications by department at a university? Yes, there is. Of course, we don't have time to get into that now, but I can tell you what the main steps are, and then maybe you want to get in touch with us to have a longer explanation. Fundamentally, you need to match up your researchers' profiles to our internal researcher identifiers. Once you have that, you can reconstruct your department groups based on these researcher identifiers, and then you can use that to query dimensions. And that allows you to do a segmentation based on your specific university structure. So that will be the way to do it. We got a new question from Bijan. Is there a SQL query for GBQ that exports a CSV exactly as the web interface exports CSVs? Right. So the answer is no. So SQL, the BigQuery SQL, it just does what it, a SQL interface would do. It just runs a query and it returns a number of records, right? But on the other hand, there are many, many libraries for different programming languages that know how to transform that SQL query into a CSV. So the answer is no with SQL, but yes with an interface library. So for example, what you see here in my notebook, let me pick a query that returns a list of things. Yeah, like this one here. What I'm getting back is a table. So that's exactly like a CSV. And that's because this command here is a shortcut for another command that essentially turns this data into a data frame. Data frame is a Python representation of a spreadsheet. You can think of it this way. So from this representation to a CSV, it will be trivial. So yes, that there are easy ways to do that. Awesome. I think I don't see any other questions. Thanks again for your attention. Stay tuned. We'll be sharing the details about the slides and the webinar shortly after this, and looking forward to seeing you again. All right. Have a nice day. Bye-bye.